All right. So, like I said, today's it's probably a little bit different from your typical seminar because I'll cover a topic that is, basically what I've been working on. But it is also something that is, I'll try to stay a little bit high level as well, rather than going very in depth, kind of an academic talk. I'll stay high level to make sure that everybody is able to follow along the way. But happy to take any questions at the end when we have time. So today I'm going to talk about three things only. So if you walk away from this seminar thinking that you learned, hopefully more than one thing out of those three, then it'll be a success. So first thing is data. Second thing is metadata, and the third thing, obviously, is probably the hardest topic right now: generative AI. So who am I? I was a student 20 years ago sitting in your seat. Who am I? I graduated from the University of Auckland with my both undergrad, bachelor degree, and master degree. And then went to the US and did my PhD at UCLA. And after that, worked at Google and followed by LinkedIn. And most recently, I started a company called Myriad, pretty much just working in that three things. That's our focus. So data, okay? Such a simple word. Everybody probably has a very different idea about what data is. But why is it important? So this article, famous article, came out at this point, 2017, 5 years ago, that talks about how oil is no longer the most valuable resource. Data is, and for obvious reasons, some of these companies are the biggest companies in the world, and all of them, the common thing across them is all about data. Data is the lifeblood of these businesses. Without data, none of these businesses could have grown to where they are today. And just to show you that data is truly more important than oil, this is Google search trend. You can see from 2014, almost 20 years ago, until now, the term petrol, given that we're in New Zealand, we're using gas, this is petrol, and the term data science, how data science overtook petrol in about 10 years ago. So I'm going to give you the official definition of data, which is pretty long-winded. You can read through all that yourself. Collection of discrete continuous value, convey information, basic unit of meaning, and all that. Very official definition. To be honest, I don't know what that means. A layperson think of data as a spreadsheet. You have columns of things and then values recorded in there, and this is data. That's how most people. All right. So now I'm moving on to the next topic, metadata. So what is metadata? I'm going to use one of my favorite movie scenes from Inception, if you remember this scene. When it talks about, you must go deeper. Right? Metadata is data about data. Okay. I'll let that sink in a little bit. Data about data. What does that even mean? Coming back to our layman definition. So coming back to our layman definition of data, which is typically a spreadsheet. When you receive the spreadsheet, the first thing you look at it, and you're gonna start asking questions, such as, where does this data even come from? And who created this data? And what does each column mean? Right? What is the ID, name, date, value? What do those things mean? You might ask, hey, when was this data created? When was the last update? Is it still relevant? And then you obviously go deeper into each column, look at every data and say, well, how was the data actually even computed? Right? There's a column called value, which seems to suggest there's some important value. But it has now in there, it has 0, 3, 4. What does that even mean? the answer to all these questions is metadata. It's data about the data. In other sense, it is the thing that gives data its meaning, if you think about it. Right? Without the answer to any of these, it would just look like any other spreadsheet. You cannot really make any valuable analysis on top of this data and try to extract value out of it. So you can roughly classify data into 3 types. The first type is, metadata in 3 types. The first type is technical metadata. So these are basically the definition of what the data is, right? And then the next level of metadata is called business metadata. Okay, it's talking about why does this data even exist, right? There must be a reason why someone captured this data, store it, and use it for some purposes. And then finally, ultimately, at least so far, maybe in the future we'll be replaced by AI, but so far, data are basically used by humans. Right? Human look at the data, human try to derive insight from the data, human set up pipeline and use data to drive other business processes and whatnot. So you can look at those behavior data and try to understand, who, where, and how the data was actually used. So these are 3 different types of metadata that you see. Right, that's all great and good, but what does that really mean? Who cares? Right? I mean, great, it gives meaning of data, but so what? If you look at it from kind of a typical enterprise setup, people who are using the data consumers, typically, your analysts, business analysts, and your business user and whatnot. These are folks that are using data to make important decisions, to drive business and whatnot. The sort of thing they care about is, hey, I don't even know what kind of data I have in the company. I want to know what it is, how to find it, how to use it. Who was the last person to use it, and once I found it, can I actually trust the data in it? Right. That's why these folks care about it. Once again, remember, what metadata is the data that gives meaning to data. Right. So once you have the metadata, then you can answer these questions and answer these folks. And on the other hand, people who produce the data in the first place, that's called these folks, data producers. Typically, they have job title like data engineers, analytics engineers, and whatnot. These folks, they love creating pipeline. They love building things that bring in data, merge data, and whatnot. But at the end of the day, they end up doing mostly supporting job. They spend 30% of their time supporting people, asking questions about the data, and they don't even know the answers to those to a lot of extent. So these people care about. They want to make sure that they can enable other folks in the company to use data productively. And finally, in company leadership, your CEO, head of data, these folks care dearly about, we spend all these money on gathering these data, processing these data, sometimes procure these data. What is the ROI? How do I make sure that the data is actually being used? And then when they are used, do they produce more value than value? And can I enable people to help themselves with the data, right? Rather than having my folks spending 30% of their time supporting each other. So these are the folks that care about metadata. Now let's take a look at it from a different angle. As a company get mature, you go through this sort of value pyramid. At the very, very bottom, think about it as, hey, I'm a new company. I just start collecting data. I just start storing a huge amount of data. I haven't really derived much value out of it. It's all about storing and collecting. And at the next level up, now we have the data collected and stored and all that. We want to make sure that we can build data and then use data in a trusted way to make business decisions. So that's the second level, which is data governance. And then on top of that, we start building reports so we can look at the things like, oh, okay, how is our customer doing? Are we well, et cetera, And on top of that, you start asking, even predictive things, right? Let me forecast, the next quarter, how we're gonna do, and so on, based on the current data. And finally, once you sort of achieve all those things, at the very tip top, that's where the real AI ML magic happens. So it is formed as a pyramid for a very good reason. Right? The things at the bottom is extremely important. If whatever you have at the bottom is shaky, then forget about building things on top. Right? So most companies, they started their data journey thinking, oh, I want to do the cool, sexy AI ML thing and all that. But they forgot about the basic stuff at the bottom, making sure that this is built on it. And then metadata sits right here, squarely in this data governance layer. How people to make sense of the data, how people to better manage the data, how people to build trust in the data. That's where metadata is. And now I'll talk about some macro trend that happened in the past decade or so. Why is this problem important? Why all of a sudden this thing become everybody talk about it? Why company care about it and so on? So the first thing on the mind is data democratization. And what does that mean? That means you want to enable as many people to make important decisions, to make data-driven decisions as possible. In the old days, you might have a CEO who just sits there and make every decision based on his or her guts, right? That is no longer viable in today's world. Now, every important decision should be backed up by some real data, not just some business acumen or whatnot. They have to be able to make these important decisions in terms of procuring things, investing in different areas, and so on. So in order to do that, they want to make sure that everybody in the company, doesn't matter what level of data literacy that you have, you want to make sure that these data skills they have, you want to enable these folks to make use of the data and make decisions based. And at the same time, a lot of new job titles are created along the way. People start specializing. It used to be, hey, it's an IT's job. IT is the one that's collecting all the data. And now it becomes, hey, look, we need to start bringing in some data scientists to look at the data, or we can bring in analysts to build up reports and whatnot. You have more and more players that want to use data. And also at the same time, there's a lot of very interesting big data technology that has happened in the past decade. I've listed a couple of them here. But the idea here is you have more and more of these systems that are specialized and more complex and try to process data and then query data in many different ways. And then obviously, with the advent of cloud computing, everybody is moving to cloud, right? And that just means it becomes easier to create more and more data. It becomes super easy to store data. It used to cost, some astronomical amount of value to store, X gigabyte of data. Now, people almost treat it as free because they're literally almost free at this point. And that just basically create more incentive to create more data. And at the same time, especially governments start coming to the realization that, hey, we cannot let people just do random things with the data, especially companies. If you're familiar with, there's European privacy laws such as GDPR, in the US it's CCPAs and other similar laws that are trying to start looking into how companies are using their data, making sure that they're protecting and respecting your privacy, right? And then obviously when data are used for making important decisions, for example, do you get approved for your home loan or not, based on some personal data, you better make sure that there is some regulatory requirement coming in against the banks and whatnot to make sure that they're following the best practice. They're not just discriminating you randomly. So there are more and more regulatory pressure coming in. And given all of those trends, macro trends, it creates a bunch of problems. Like I said, finding data becomes much harder in the company. And trusting what you found is even harder. And then finally, even just managing that huge amount of complexity also becomes difficult. So how do you solve that? Obviously, we're still on the topic of metadata. So I'm going to be very, very biased. The way to solve it is through some sort of centralized metadata platform. And what does that mean? Think of it as a place where you extract metadata from various sources, centralize in one place, and then on the other hand, bring in other contextual data such as business metadata, the description, tribal knowledge, tagging, all of these things, centralize in one place, and then use that collection of metadata to drive various different use cases that you want to solve for. Okay. Right. Now moving on to the third topic. Generative AI.
Yes, that's fine.
Okay. Obviously this is a topic that a lot of people are talking about lately.
Oh, lovely.
But
Thank you.
some people when they hear AI and how great AI is, the first thing
There's a cable factory in Vietnam that I want to go to.
but the good news is
LSV now.
generative AI is not able to create Skynet.
Do you know where?
But it can do something like this. This picture that you see here is created by AI.
So LSV now does
what
this.
we call a prompt.
You know of it?
Yeah.
By giving the AI,
Yes.
hey,
Yes.
a simple
Cool.
description
So,
about the picture that you want to
when I
generate,
was in Australia,
it's able to generate a picture that looks
we
pretty
got
darn
some
good,
life
right?
there,
If you look
but
at
I never got to go
it's
there.
almost like a real person illustrated.
Thank you so much.
But of course, if you look at details, and if you're
Enjoy.
aware of these things, you'll probably notice that the robot has 6 fingers rather than 5, which is rather abnormal. And on the other hand, maybe 3 or 4. But obviously, this is getting better over time. And I'm sure a lot of you have played with ChatGPT. You can obviously ask questions like this, and you'll get pretty darn good answers as well. Always. You can see it's trying to be polite. We all know that it's always the case. All right. So in the heart of all these generative AI is something called a large language model. Okay, you probably heard of this term, LLM. Okay. What is it? Okay, to understand what large language model is, let's start with small language model first. And small language model is something that you're probably very familiar with. You've been using it for quite some time without realizing. Here's an example. When you type something in the keyboard, you realize that the keyboard is helping you to predict what the next word should be. And how does it know that? It's actually a very simple statistic, right? It basically looks at some commonly used text and then figure out what's the probability of the next word based on the previous word. Right? So maybe when you look at all the Wikipedia entry, you realize what comes after Kant is either way to believe or remember. Those are the highest probability. Right? And you can sort of extrapolate that. So this is small language model. Okay? But if you take this to the extreme, okay, what I mean by that is instead of just looking at the immediate word prior to the text you're trying to type, why don't you look at every single word in the text and see how that's related to the current word, the next word you're trying to predict. And then you train it on huge amount of data and using some fancy AI algorithm, transformer, if you're familiar with that. You can actually create something that's pretty amazing. So the best example I can think of for large language model is an example that from the chief scientist from OpenAI. He mentioned this very, very good example. Imagine that you are writing or reading a Sherlock Holmes novel, right? You started from page 1, you start setting up the scene, talking about all the people, you start talking about, someone got murdered, this thing happened after that, etc., etc. And at the very, very end, Sherlock come out and say, the villain is blank, right? And if your language model can correctly predict what that next word is, that means your language model understands the entire text, right? As a human, after reading the book, you probably have a good guess of who the villain is at that point. You have your conjecture. But if the language model can understand that and then predicts the next word, then the language model has almost like human understanding of the text if you think about it. Right? This is no longer a simple keyboard, predictive input. Right? This is actually, the asset intelligence if you think about it. So the reason why ChatGPT can answer you all these questions, or you can have like a funny conversation with ChatGPT, feel like it's a human. Think of it as basically it's trying to complete everything that you instructed to do, based on all the tasks they're missing. Another good analogy is, so this is where the large language models sit, right? At the very top end, we have something called general artificial intelligence. Right? It's like, okay, real human intelligence, machine can achieve that. And machine learning, most of the machine learning algorithm is considered pattern recognition. Given some sort of patterns, some fancy mathematics construct, eventually we'll recognize that this pattern is X, Y, Z. And inside of that is neural network, especially artificial neural network, deep learning. That's where this thing sits. The language model is right in. So if you really want to think about what large language model is, it is essentially a parrot that have read pretty much everything that you can throw at it, and then try to mimic that as a human. But it's doing it in such a nice way that it feels almost like. But yeah, not terminated. Right, finally, the last piece I will talk about is how do you apply generative AI in many now you can think of it as, hey, we have trained something that is, almost feel like it has intelligence. How do I utilize that in the context of metadata? One thing you could do, and here's a real example that many of you can probably relate. This is being academic, probably you do more emails than Slack messages or Teams messages, but the same thing applies. Imagine yourself chatting with someone, asking a question back and forth 20 times, 30 times. Eventually, at the end, you reach the conclusion, right? Eventually, you find the table that you're asking for. Eventually, you find the report. Eventually, you understand how this definition works. Or eventually, you understand that, yeah, you have to hand in your assignment, otherwise you get failed. Right? So once you reach that end, that is knowledge, right? And sometimes you want to capture that in your system. But most of the time, people just shrug their shoulders and say, yeah, too much work, right? How am I going to go in there and reread all that 20, 30 email and then write down what's worthwhile saving out of that? And generative AI is very, very good at this. Large language model. You can throw a whole lot of text at it and say, hey, help me summarize this. And it can do a very, very good job of summarizing. Another thing you can do is to help you with documentation. I think anyone who have not done any actual engineering work can probably compare that documentation is a laughing at anyone can do. But it is important, there's no doubt about it. So why not offload or outsource this important but boring task to AI? And you can absolutely do that. And you can do it at a level that is pretty amazing. Right? So here is an example. You take this, sort of semi-structured JSON log, and then just give it to the large language model with the correct sort of prompting. It can actually generate pretty darn good summary or description for what you're looking for. Obviously, this requires a lot of tuning, requires a lot of what we call prompt engineering, and obviously your input data has to be reasonably good for that to happen. But imagine essentially anything if you ask a human to do, a reasonable human to do, and then the human can, given sufficient amount of time, will do a good job. That is actually a perfect candidate. And another thing, this is where, when OpenAI first came out, a lot of people, the first reaction they have is, oh my God, this thing is gonna kill Google. It's gonna completely replace Google. And the reason behind that is really understandable, because if you look at most of the search people put do online, they're essentially asking questions and trying to find information. right? And what Google is really good at is doing this keyword match, and then do good ranking out of the result. But still, you still end up having to click into each result to find, and then through maybe sometimes you're lucky through the expert you can see where the answer is. But a lot of times you have to still click into it to figure out whether that is something that you want. And large language model can actually take all that and then just give you an answer that you want immediately. And anyone who have tried ChatGPT can probably attest to that already. So, in sort of enterprise setting, this is actually very, very critical. A lot of times people just want quick answers. Spare me all the detail. I don't want to read 20 documentation pages to figure out what it is. I want to be able to ask a natural language question and get a natural language answer. And sometimes you can even do this sort of proactive probing to the user and say, hey, look, did you ask this kind of question? Have you thought about these other questions that are related? And then a lot of time people will do this way and then explore and find out more information about what they're looking for. And finally, hallucinations. This is probably one of the biggest drawbacks of large language models is that it hallucinates. And what does that mean? This is where the parrot analogy comes very handy. Right? No one will ever mistake a parrot actually understand human and speak human. And then parrot will probably sometimes speak the wrong words and so on and so forth. Large language model exactly the same. Majority of the time it can do pretty good and accurate, give you pretty good and accurate answer. But every now and then it will just come up with something random. Because if you really look into the AI model behind it, it is trying its best to answer anything that you throw at it, right? Even if it's nonsense. So this is a problem, right? Because it will be cases when you ask a question and then every 10% of the time you're going to get some random answer, and then you trust the answer thinking that is good. That is generally not acceptable. Here is an example. You ask a large language model who is the captain of the All Blacks, right? Even if the large language model is not hallucinating, it's limited by whatever input data it has. In this case, it might be trained on some really old data, and then it'll say, oh, Richard McCaw is the All Blacks captain. Obviously, that is outdated. In some cases, it doesn't have the answer. It might just come up with some random answer. That's what. So how do you prevent that? You do it through something called retrieval augmented generation, RAG. This is actually pretty ingenious if you come to think about it. So instead of directly interrogating the large language model and then get an answer from the model, you actually think of large language model as a pretty capable person of determining based on some sort of input, right? Not as a model that's going to come up with an output. So what does that mean? What you do is you take the original question, who is the All Blacks captain, right? Instead of throwing it at the large language, what you do is you send it through what we call embedding model, okay? And what the thing does is it takes your sentence and then return what's called embedding vectors. That basically has a large, huge number of numbers in it. And what this numbers mean is in a high dimensional space that maps to a concept of what this language, what the question is about. So think of it if you ask a question about, who is All Blacks captain, right? And then you ask the next question, who's Black Caps captain? If you look at the two vectors that's produced out of the embedding, there are certain parts that will be very simple. For example, it is a question that is asking about something. Okay, that part will light up. It will be very simple between the two. It is a concept of captain between those two questions as captain. Those parts will line up pretty well. All Blacks and Black Cap may be closely related as well, right? But then they might be very far apart in some other senses. They're closely related because it's all New Zealand scene. Very far apart because it's not the same sports. And once you have those embedding, you take those embedding and then input it into something called vector database. Okay. So what this vector database does is you input all the information that you would like the the language model response as document ending, as embedded. Okay, and then the vector DB will try to find the closest embedding for you based on some nearest neighbor always. Okay, so think of it as it's a way of filtering of all the documents you have in vector DB and find a document that's most relevant to whatever is being. All right, then we'll get a bunch of documents. You know, some of these documents might actually contain the fact that, hey, the All Blacks captain is so and so, and some of them might not. Some of them might contain, hey, All Blacks, won the World Cup last night. Something like that. Then you take all these documents and you take those documents to the language model. Now, instead of asking the language model directly who the All Blacks captain is, you ask the language model, say, hey, look, I have all these references for you. Can you find out who the All Blacks captain is based on whatever I give? Okay. And language model is very good at that. Most of the time, it will not hallucinate based on that. So with a combination of that, you basically use a language model almost like a human brain. Think of it as, and then you say, hey, look, I have this very mundane task. I'm giving it to you. Why don't you do it? And that's how you solve, hallucination problem. All right, so that's all from me today. Hopefully, you learn a thing or two from this. I'm happy to take any questions.
It's a very complicated topic, but you explained it so well. So even people like me in the area still understand, if not all, most. Okay. So any questions?
Yeah. Yep. With respect to that last slide you had on the RAG, how do you create that big database?
Yeah, sorry, I skipped that detail a little bit. So what happens is you use the same embedding model. So think of the embedding model as sort of summarizing this long text into a bunch of numbers that has meaning that is associated with the text itself, right? So you take all the things that you want the large language model to answer. Right? For example, if you take All Blacks history page, and then it has all the captains and then the years and so on and so forth. You take all of that, generate embedding, and then put it into the vector database. When you ask that question, who's the captain of All Blacks, you're going to generate an embedding that is, surprisingly very, very close to the information that contains the precise information you're looking for. Right? That's how you do this retrieval.
Just considering to add embedded to LLM, how much computational complexity would be increased from this stuff in case.
Yeah. So large language models are very, very expensive to train, right? There's some figure being thrown around, tens of millions, hundreds of millions to train like a really good large language model. These are all foundational. So think of them as general intelligence. The benefit of doing RAG is to say, I don't want to fine tune my model. Right? I mean, one way of doing it is to say, hey, look, why don't we retrain our model with these added information? Then we have a model that's capable of answering that. But the problem is doing that is extremely expensive. Not everyone can do that. So what they do is to, instead of doing that, is say, hey, can I just have some external sources of information to augment the foundational model, doing it through RAG. So in terms of complexity, it's actually pretty light. It is not something that is very heavy. And this is definitely a lot of companies are doing that right now. There is the other camp of people who are investing heavily on how do we make sure that we can reduce the size of the large language model, make it very cheap to train, open source and all these things, to make sure that anyone who wants to do it can fine tune it and build their own model. But that part is still kind of, the jury is still out on that, which approach is really going to win out. But based on our experience working on this, RAG actually works really well in most cases.
There's something related. Can we compare it with transfer learning?
Yes, it is actually similar to that if you think about it. Yeah, yeah.
Yep. Dr. John?
So this MetaDB, is it a manually defining process or it can be automatically extracted by AI itself?
So the VectorDB is just a database that basically can be embedded very efficiently. Because think of it, if you have 2 points in a Cartesian axis, then it's very easy to calculate the distance, right? Basically, just delta x, delta y, square root, right? But if you're in hyperdimension where there's hundreds and thousands of embedding, trying to find the closest point in that space is actually pretty complex. Right? So VectorDB is something that is specialized for quickly finding out in this high-dimensional space how the 2 points are closely related. So the database itself doesn't contain information. You have to stick information into it. But it is specialized at this job of quickly find out the closest point.
Is that database already in the system, or you provide additional data?
No, this is something that you bring yourself most of the time. You create this yourself. And there are companies that are specialized in building vector databases, open source vector database as well. But it's being quickly commoditized at this point. Most of the traditional database vendors start offering vector database capability.
I remember once I tried to trick ChatGPT, so they give an answer. It's not quite right. I said, "Are you sure?" They changed the answer.
Yeah,
So
that's the hallucination part, right? Because it will just try to complete you always, right? Because it's hard to complete the next word and the next word, right? So it will try very, very hard to do that. And majority of the time, if you the right information, it will be able to do that. But when it's missing information, it will still try to do that based on its all the parameters. So
more.
So
Okay.
for the embedding model, is it something autonomously constructed, or you have to define that based on?
So embedding itself is actually quite complicated topic, but the way to think of it is, you try to figure out. So first of all, you have all the words that go into the embedding model, and then your task of this in and of itself is an AI model. So we'll take all the input training data coming in, and then try to figure out the relationship between those. Once again, the concept, why is all blacks and all black cats are close together? Why is men and women are probably close in one dimension but very, very different from that. It's doing that from a statistical point of view, try to compute all that. So it is a model that is specialized in computing those embedding. And all the time you have to match up the embedding model and the actual large language model. It has to be the same model. Otherwise it won't.
Yeah, so and kind of related to this with stuff that he was talking about with respect to metadata. In terms of referencing, I know with large language models, ChatGPT, it can spit out rubbish data, but because you have no idea where it's come from and where it was generated, the date of the data and everything, it's difficult to determine whether it's rubbish or good. Is that where are those capabilities coming into play as well with equipping large language models and with those capabilities of drawing out that data on the data within its answer?
Yes. If I understand you correctly, what you're saying is how do we use AI to draw the right kind of data? Is that what you're draw?
Yeah. I suppose relating what large language models give us, the data, the output data, is there data on that data?
Oh,
that's being,
I see.
sort of relating the two. Yeah.
That's a very interesting question. I don't think I've seen anything like that quite yet. Metadata on large language model output data. That could be an interesting thing to find out.
Yeah, some people online are asking for your slides. So maybe they can contact me. If are you happy to share the slides?
Oh yeah, yeah, definitely share the slide and then recording afterward. Let me see if there's any
Yeah. Very informative. Yes, I'd like to get the slides. Okay, any
other questions?
other questions?
Yeah, but this question is like, what kind of programming language should we use for the, let's say, generating AI or other stuff?
Right. In general, data science, the sort of de facto language is Python. Right? That's what people use the most. But in sort of generative AI specifically, I think Python will be still dominating, but we do see more TypeScript as well.
What's that?
TypeScript, which is like a type JavaScript. I think the reason behind that is a lot of these things has immediate application to sort of web-oriented application. So a lot of the web developers also want to get it. In fact, I think they are, if I remember correctly, the browser itself also has a capability for you to run small, not different, reasonable size things rather than browser itself.
Yeah, thank you.
Great. Any more questions? Okay.
If you offer this kind of service as a cloud service to the enterprise, how do you deliver this capability to the private data inside the organization?
That is a great question. Actually, so obviously, the whole thing sort of started from OpenAI first releasing ChatGPT, and people also go crazy for this is like the best thing ever, right? But then Microsoft, which invested in OpenAI, they all has the right to use OpenAI in the Azure cloud. Right? So they actually provide a service that's inside of Azure cloud that is sort of private to just that organization. And then they basically set it up in such a way that people can trust that, hey, my private data is not going to be used by Microsoft training. And OpenAI didn't immediately, follow the same line, but it was still being a little bit ambiguous about, how can I use your data? Your data in ChatGPT is going to be stored, it's going to be used for training and all that. Only until later they came out, oh no, we're not going to do that. But I think that the well was really poisoned at that point. So now most company, the one that we work with as well, when we talk about AI, the first reaction is definitely no OpenAI. We don't want people, we don't want you to send our data. But when you say, look, you can use Azure OpenAI, which is literally the same thing, right? Then they say, yes, that's okay. That's not our Azure. So yeah, companies are definitely getting smarter and sensitive about this now. They will demand you explain how you intend to use it, rather than just writing, oh yeah, this is great, I want to take advantage of this. So ultimately you have to kind of bring all some of these components right into the old cloud or the old environment to make sure that it's comfortable across the data.
So when you make AI to read the enterprise private data, does that data become part of the global knowledge database, or you can isolate the public and the private?
Yeah, most of the time you will have to do isolation between private and public data, and most companies will have access.
Yeah, that's definitely a big concern, right? Even in university, so we have been discussing whether students are allowed to use ChatGPT to write up thesis or finish the assignment. One concern is if you put the information there, so would become public. Yeah, so it will be disclosed.
Yeah, and I think people have shown in
cognitive research
many times already, you can figure the language model, just figuring out the training data, which someone who's actually taking PII as well, right? So yeah, it is a topic that people are trying to very, very carefully about. Yeah. And I think even the EU is trying to put out some law around this as well. So I think it's going to be an important topic.
Yeah.
Okay, this is Andre Kuppen from online. Can you hear me?
Join me again to thank Dr. Len for the really exciting. Okay, so I think the party is over there. So there may still be food or drink there if you like to.